Yeah.
I
Yeah. Yes, good afternoon, ladies and gentlemen. Bonjour. My name is Gregor Stolarczyk, and on behalf of ZENIT, I would like to welcome you to our today's webinar, which we organized together with our French colleagues from the region of Hauts-de-France. It is within the framework of a scientific cooperation that exists between both regions, North Rhine-Westphalia and the regions of Hauts-de-France. And I think it was last year or 2 years ago, we organized already a session. It was in a virtual way about bio-waste management. And we thought that our upcoming event during Anuga Food Tech in Cologne, which begins next week, is a good opportunity to take to refresh on this topic and to continue talks and to see what kind of opportunities there are currently. Yeah, I would like to hand over to our moderator today, Ms. Miravo Rakutovao. She's a bioeconomy expert in the region of Hauts-de-France, and and a bigger expert and an expert in this topic. That's why, Miravo, the floor is yours, and
Thank you,
enjoy.
Gregor, for giving me the floor. So, good afternoon, ladies and gentlemen. Welcome to this edition, this second edition of webinar dedicated to the issue of bio-waste. So let me introduce myself. So I'm Miravo Rakotovao. I'm Bioeconomy Project Officer at the Chamber of Commerce and Industry in Hauts-de-France region. And if you have some, so I think, regarding the regulatory context on bio-waste, the main aim of this conference is to share experiences and best practices about sorting, collecting, and treating bio-waste, especially in the field of food industry. And it is also organized with in the field of Anuga Food Tech. So you have all the information about this in the email. So do not forget to see and to take the time, because there are many topics that will be treated in this conference that will be held from 19 to 32 or 31 of March.
20 to the 23rd of March.
Yeah, 20, yeah, 21st. So, sorry. As we have many speakers, we have 7 speakers today. Let's begin with our first speaker, but if you have any question, do not hesitate to interact by the chat. We'll try to answer to some questions. But however, at the issue of this webinar, we will have also the opportunity to get in touch with our speakers. So do not hesitate. So welcome to our first speaker, Louis Louchard, who is head of project at TACE, a French company specialized in providing solutions for industrials and municipalities to deal with their environmental issues. He will present us their biogas production, deconditioning, and hygienization project. Louis, I give you the floor.
Yes, so hello everyone, I'm Louise. As said Miravo, I'm a project manager at TES. So today I will give you a quick overview of the TES Society and then what offer do we want to give to industrial to manage bio-waste. TES Enterprise is a family business. It's a 90 years old company. It began in the sanitation, then in cleaning, and since 2014, TES has developed in waste management. Today is almost or around 200 employees, and we work mostly in north of France near Douai and Valenciennes, and we have a 24/7 on-call service. We work for individual, local authorities and industrial as well. So we can give an offer to a lot of environment service to industrial, from sanitation to waste management. Here is the organization of the society with all subdivision, and you have in a green circle all the company that works for the bio-waste management. So we have from a collection to preparation and then methanization. And we have other enterprise in sanitation and cleaning. Here is a map of the different entities. And as I said, it's mostly in north of France. We are a family company, so a human being is really at the heart of the company, and we want to give answer to industrial for a very specific problem where big company doesn't really want to go sometime. So that's all for the presentation of the company. So as I told you, it's a family company, 200 employees on different kind of work in the environment subject. So now here is the specific offer for bio-waste. I put a little bit of a regulatory context, but I'm pretty sure you all know about this, so it's just the big view since 2010, and now end of 2023, 24, we have obligation to give a local authority have obligation to put bio-waste sorting for everyone. So we think it's important for a group like us to offer a local solution. And that's why we developed since 2 years the bio-waste treatment. Our service is going from the collection and put a collecting bin on place, then unpacking, and finally the methanization and biogas valorization through the network. Concerning the pre-collection and collection, it's necessary to provide the appropriate equipment because bio-waste will change very quickly. So we can offer from 600 liter per box to 30 cubic meter cheaper. It will really depend on the type of industrial or individual that will be served by the service. And like we have a very different kind of collection equipment, we also have a different kind of waste collection truck, like a watertight truck, tot liner, tailgate, or a moving floor truck. So it's really important to have all of this to respond to everyone. And after so when you collect, you have to prepare the material to go through the methanization or a composting plant. So we are having a project about a sorting and recovery of bio-waste. So it's an unpacking and hygienization site for 15,000 tons per year in Douchy-les-Mines. And it's a 4 million euro project with a ADEME grant application. And we think that 4 people will be necessary to operate and do the logistic on site. So it's again a significant amount of money that need to be invested for such plant. So it's kind of tricky. Here is a implantation site in the green area, and you can see we have 2 other waste management plants and one waste to energy plant, and that's why we thought about this this site like that. We will use the heating network from the waste to energy plant, and energy cost is a real problem, or it could be hard to handle for the next year. So it's easier with a heating network based on waste valorization. Here is a little view of the plant that we designed, and it's subject to a new regulation rubric in France, specific on unpacking and hygienization. Sorry. So we have different reception area depending on one kind of collection truck we have. Then there is several steps, the unpacking, which is the main first step. And after we have a step to wash the refusal, who are mainly plastic. But I know that Benjamin, after me, will show more in detail the process, so I will let him introduce that. And after we have the hygienization stage through the waste to energy heating network. And finally, we have another purification of the soup, because if we want to have a sustainable activity, we need to have like 0 inert or plastic in the soup, which finally goes through the agriculture. So that's why we need to have a really clean soup. And on the other side of the site, we have all the cleaning and hygienization of the container, because if we need to have a really clean material for the agriculture, we need to be really clean for the food industry as well. So it's important to manage the cleaning of containers. And on this site, we thought about the following tracking of the refusal, because it's also important for industrial to know where their bio-waste is treated. So the unpacking was the pre-treatment, and the test wanted to offer a complete chain of valorization. So from the collection to the final valorization with methanisation. And locally, we had a project with a regional natural park and several farmers. This group of people reflect on the project and wanted to include bio-waste. But as it's a new project for a farmer, they do their farmer job. Now energy with methanization, they didn't want to go too far away and have a bio-waste management. So they asked us to come in the project. So since 2021, we testing group enter the project of methanization. The methanization project is 32,000 tons per year. So it's not that big, but it's kind of big, with 7 agriculture in mixed crop and livestock farming, plus us with bio waste. So in this project, bio waste is only a quarter of the inputs, but it's more than the third of the biogas production. So it's really interesting for a farmer. They put less crop in the methanization, and it's good biogas production. For us, the construction budget is around 8 million. So when you add the 4 million for the unpacking, it's a lot of investment for a family group. And on this site, two employees will be necessary to operate the site. You have here a quick overview of the methanization site. I let it like that, and you will have the presentation if you want to have more detail. You are free to ask. So I'm at the end of the presentation. Right, almost on time. So thank you, everyone.
Thank you very much, Louis, for this interesting project and presentation. So let's take one question from the chat, or no, it's Gregor.
That was just a reaction, but I have one question, Louis. So you said that there was some budget mentioned and some investments. Is that with the help of the European Union, or is that the French state will support you, or the region? Can you say a bit?
For the unpacking project, we can have help from the government through the ADEM organization. And for methanization, it's dependent on project. Sometimes you can have help from FEDER, which is the European grant organization, or ADEM again. And for our project, it will be ADEM grant. And it's still kind of necessary to make this project valuable.
Yeah, I can imagine that you need some supporters, in that. Yeah.
Just
okay.
For instance, for the methanization, it's at 8 million euros project, and we can have 700,000 as help.
Okay.
It's less than 10%.
It's still necessary. Okay, so thank you for your answer. So now let's move on to our second presentation. Welcome to our second speaker, Timo Broeker. Sorry for the pronunciation; it is not a good one.
It's pretty okay.
Mr. Broeker is Transfer Manager Environment and Resources at the Technical University ODL in Germany. His presentation is entitled Bio-Waste Management in the Food Industry, Waste Bread, Ethanol and Biorefinery Concepts. Mr. Broeker, I give you the floor.
Okay, thank you very much. Merci beaucoup pour l'invitation et la possibilité de présenter notre institution pour notre ami français. And now I will switch back to English right away because that makes it easier for me. So, just a second. Here we go. Okay, I'm gonna give a short overview of what we have been doing, where we are coming from, and what we are dealing currently with in our research projects. We are a University of Applied Sciences, and me and my colleague Imke will be at the Anuga Food Tech too. So maybe further questions and ideas we can discuss then. A short overview, we are a mid-scale University of Applied Sciences, 6,000 students, 24 million euros of third-party funding, which is a pretty good rating in Germany for a smaller University of Applied Sciences. We have about 800 employees, and something we're pretty proud of. The students voted us the third liked University of Applied Sciences in an online ranking, study check ranking. This is just a slight commercial, but this is something that comes from the students. So this is my favorite thing to present if, I have to give a short commercial. But now let's get to the topic we're all interested in. First of all, to see where we are located at. East-West failure is a little bit confusing. So this is where we at, all in the east of North Rhine-Westphalia. This is a map which shows, it's a little bit older, but it shows power to gas projects in Germany. So I use this because we are listed here with our energy park project I'm gonna talk about in a minute. This is an overview of the campus in Lemgo, which has been growing quite a bit, and something you can see here, this is the old building from the 70s, the main building, and what you can see here, that's pretty interesting. Something we build new and are operating in already. It's the Future Food Factory, so something, some place where we really are able to operate things in practical terms. This is a short overview from the outside building and what we are doing and caring about. Its quality, shelf life, individualization within industrial processes. A big thing is resources and energy, of course, in food industry, and that concerns cradle to cradle questions and things we are talking about today. And transparency and authentication is something really important too. That's a short view inside the facility here. So there's offices, and there's also really a facility to do research together with companies and partners. Okay, what have we been doing in this field, residues and side streams? Let's go all the way back to what I've been starting out with here, some old projects. We really did care about the whole process line and the whole cascade of using biomass from brewing beers or making ethanol to biogas, and then hydrothermal carbonization to do the whole cascade and have the most output using residues. Also, we started to use the carbon dioxide and asked, what can we do with this? Started to do a methanation. And if I talk about methanation, I'm talking about the pure process where we add CO2 and hydrogen, green hydrogen, in order to produce methane. So there's some of our equipment. The upper picture, that's hydrothermal carbonization. You can see 3 zones that heat up the biomass, bring it into the high pressure and high temperature reactor zone, and then comes back out to not lose too much pressure and temperature in the middle. So this is, you can see a big screw In front of this thing to press everything in, we have one of my favorite toys is the distillery down here. And we also did care about disintegrating lignocellulosic materials. 2011, we had a project to make bioethanol from waste bread. This is a picture of a real scale trial with 10 tons of waste bread. We produced 2,450 liters of ethanol. So just couple things we started with. This is another picture of the coupling processes. With this plant, we also activated, we called it an activation, disintegration of lignocellulosic material, activating material to have better output in fermentation processes, whether it's ethanol or biogas processes. Okay, so this is what we have been dealing with, but kind of moved further. Let me show you something we have been doing in about 2018-19. Something we still are really ambitious about is proteins and peptides. You can see a short overview of a process line to process residues and agricultural side streams to produce optimized proteins and peptides, optimized in terms of function and optimized in terms of nutrition or nutritional values. And the main thing is chromatography, a process chromatography to fractionate the peptides. That's an award-winning technology because we won the Go Bio, this pretty good dotated German funding with this technology. What is it all about? Usually you have different kinds of amino acids in a protein source, and then you can fractionate them, and in the end you get a kind of a wild mixture of whatever you can be able to hydrolyze. But with the chromatography method, we are able to separate all the different amino acids, and in the end, we can take the essential ones, the good ones we want, and put them together to a tailor-made and optimized product. And we're still convinced this is something pretty innovative for the future, but the problem is we need to go out of lab sometime in a bigger scale. But this is a pretty fascinating project. Okay, now the picture of something I showed you before, sector coupling. Told you we were moving ahead with the methanation. This is our energy park. It's about 10 minutes from the university. There's a biogas plant here, PV, open air solar power, and we built a field lab. There's a couple pictures. A couple more. So what we build up here, we have a methanization reactor, electrolyzers to produce green hydrogen, have a fuel cell. We have wind power plants, PV power, solar power, to operate and to experiment with the whole process chain, basically. I'm going to go through pretty quick. There's a couple of views inside. You can see the stirred tank reactor, the bioreactor for the Catholic methanation, the electrolyzers, and all the rest of the technology. So this is how it's supposed to look like on the outside. It's not, but we care more about the technology. Okay, this is a technical overview of the whole thing, including the buffer tanks and all this. But in order to be in time, I'm gonna skip a couple ones. This is pretty interesting because we kind of calculated, is there enough biological CO2 from ethanol, from fermentation of beer, wine, champagne, or biogas, and according to what we need in different scenarios to store renewable energy, we have significant amounts of CO2 from those sources, and we're saying, okay, CO2 sources from fermentation are pretty cheap compared to if you want to do direct air capture or something different. So this is a short look into the bioprocess. We have a 65 degrees process at a pH of 7. And we can raise the pressure up to 5 bars in this reactor, which gives us the opportunity to optimize quite a bit. So there's optimization, temperature, or faster stirring, which results in higher gas production. So this is something we deal with. Let me skip this. But
Sure.
you know, okay.
I'm running, sorry.
Okay, cool. Let me see. This is probably, yeah, this is pretty much it. Let me finish with this one, and then I'm done. What we right now, what we're doing, we have like a digital twin to do experiments with different kind of surroundings. And if you have other ideas, don't stop or hesitate to contact us. And this is my short overview of what we've been doing. Thanks a lot, and ready for questions.
Thank you very much. So we have one question from Marina Billinger.
No, I don't have a question. It was just applause. Thank you so much, Timo, for the presentation.
Thanks a lot. You're welcome.
So I have one question. As in France, we eat bread more than Germany, I guess. Are you interested in working with some French companies, industrials, and how do you manage the collecting and the sorting of the bread? Is it from industrials or from the municipalities, or how do you manage the sorting?
That's the very good question, because we have different sources, different regulations, depending on whether there is rests of meat in there or something. So we had 2 different kinds of collecting pathways, basically. So one is really from supermarkets, whatever they sort out and take back, and the other one was big bakery chains. For example, the one that's on the Frankfurt airport, we've been working with because they have a big mixture, and ethanol was really the only thing. They couldn't put it in cattle feed pathway, or biogas was a problem. So really that was something for them to deal with. But there's a big part of private waste. We don't have an idea yet. We could put up boxes, people can put it in, but I don't know. This is a big part you cannot get a hold of really easy.
Okay. Thank you very much again, Mr. Broker. So now
My pleasure.
Now let's please welcome our next presenter, Mohammad Mohammadi, CEO from Collecte. He will share his experience about the digital solution for bio-waste management in the food industry. Mr. Mohammadi, could you tell us more about your company and your solution, please?
Of course. Hello. Hello, everybody. Hello, everybody. So, first of all, if I want to share something, before starting to presenting what is the collector, I want to say thanks for inviting me for the webinar. I think we are really in another side because in collector we are in the I can say we are in the first mile or kilometer of waste collection. It means collector is a platform for circular economy. We are a startup. I know it's not really common that finding innovation in the maybe collect or transport for waste collection. So collector is a startup, is a digital solution, is a platform. I should emphasize in the word platform for waste collection and transport. I can say that it's more than 2 years that we start Collectro. Collector is a label by French government as a French tech startup. It means the government, we have some grant of government. Just right now, it's not a big one. But we are going to digitalize the market because we believe that IT is not yet really touched the market, especially in transport and collection, and we can do a lot of things. We can do a lot of optimization in waste management. Especially when we talk about the collect or transport in optimization. In the article, in the university article, in the academic article, we say that we can reduce the cost of the waste about 14% by planning of collect. That's the real challenge. As you know, in Europe we have two issues for collecting the material, especially the material that is not really the value. Best example, I think, is the bio-waste. We have two issues. First of all is the cost of the fuel, and the second one is the cost of the how to say
Mohammad,
HR.
it's still the first slide. Is normal?
Yes.
Okay.
It's okay. And the second one is the HR subject. Finding the person who we want to collect is not really simple in France. I think in other country like Germany too, it's not really it's not really easy to find someone for collecting. So in collector, we have some assumption and hypothesis that if we want to collect something, we should work together. We should optimize the process of collect for reduce the cost of the collection. I don't in collector, fortunately or unfortunately, I don't want to say the best practice or the success story. I want to share first of all some failure story in our region, because we have, as you know, from 1st January collecting the waste producer who who generate more than 5 tons of the waste, you should find the contractor for just collecting the bio-waste. Me, myself, and my staff, we had a lot of door by door the meeting with the restaurant. We had more than 200 meeting with the restaurant in our city for convenience the restaurant to separate or sorting the bio-waste. Really is not really or easy. It's really complicated. It's really complicated for convenience, and the second subject is cost. If I want to share the cost for us, the CAC, as you know, the startup CAC, cost of acquisition, is really important. The CAC, the cost of acquisition for us is about €200.
So are you sure it's normal that it's still the same slide since the beginning?
Yes.
Okay, because
yes.
okay, because you already say that. No,
it's okay.
Now it's smooth, so you can.
Yes, okay.
So we are on the second slide.
Before starting this topic, I want to say again our hypothesis and our assumption. We say that because of two crises, COVID and Russia-Ukrainian war, the sustainability really accelerate. It means the business model of sustainability, because of the problem of raw material and the problem the energy, we say that it can be more and more the sustainable business and sustainable startup that they will come to the market. But the problem yet exists. It means the cost of the acquisition is too much, and cost of the collect, cost of the transport is not the really easy for is not really easy. So in Collectro, we say that we should work together for solving this problem. We launched Collectro. We said, and we negotiate with some of the waste collector, especially the collector who work in the collecting in the bio waste, and we try to digitalize the two sides of the market. First of all, the restaurant and the waste producer, and the second one, the collector, the company who want to collect the material. So in our region, we have this is just the example. In our region, we have more than 15K waste producer who should find a contractor just in the bio waste. And again, in our region, we have more than 25K restaurant. So it means it's the really potential for methanization, for digesting, or other solution like other solution. We develop application like other urbanization application, I can say. We have one application especially for restaurant that can manage all of the waste subject. We can say we developed in French we call it guichet unique, or in English we can say a one-stop shopping for waste management service. It means from the bio waste, for bio waste, for landfill, for renting the service just for example, for dumpster or something like that. We can propose all of the service for to each restaurant or other actor like that. And in other hand, we have that's the first application that is possible, is available right now in Apple Store or Play Store. And we can really, we propose something in French, we call it attestation de valorisation. It is the document, the paperwork that we completely digitalize that for restaurant. How many that they generate the waste, who was the waste collector, and what the next step we are going to develop the bilan carbon or carbon footprint, and the second hand, in other hand, is the our application for waste producer. If I just want to share our dashboard. We have a dashboard for waste producer, because we believe that we are in the planning industry. Heart of the solution is the planning. If we can optimize in the planning of collect, we can have the profitable business model for collecting. As you know, maybe for collecting other type of the waste, other waste types, for example, plastic or electronic or metal, it's really easy to have a business that is really profitable. But in the bio waste is not really easy, because the result, the waste in the I can say that the value the waste is near the zero. So we should find we should make progress and optimize the process of the collecting. And we have here, this is our dashboard for waste collector. We have this dashboard, and more than that, we have an application for routing for a driver who want to collect the waste. It works based on the planning.
1 minute left, please.
Yes, okay. It works based on the planning, and we have an AI that's if I can say more about it after. Here we are.
Okay, so thank you very much for your presentation.
Thank you.
Do you have a question? So it was clear. I will have one question.
Yeah, of course.
Is your solution adapted to and suitable more for urban areas? Because there is a big quantity of bio waste in rural areas in comparison with in urban areas in comparison to rural areas, because it will be more difficult to optimize bio waste collecting if it is in rural area. So is your solution more interesting for urban areas or for both of them?
I can say we are going to develop the new functionality of the services that works based on the AI. It means it works based on a statistic that we can predict the waste production of each region. I know, as you know, the problem of the rural area is one of that is the traffic jam. Because if you want to collect something, especially when there is a density of a lot of restaurants, it means there will be a lot of traffic jam in there. So cost of the collect is too expensive in this situation. It's more 2 months that we started developing the solution, especially for a rural area. It's based on the IoT solution that we can predict and propose the best time for collect. We work with 2 elements right now: the traffic, the real-time data traffic of the city, and the statistic of the vitesse, the rapidity of the waste production.
Okay. So thank you very much.
Thank you
for your contribution. So our next presenter is Marina Billinger, CEO from Leroma, a young German startup company also, which activities focused on a product-oriented search for relevant food raw materials in the B2B sector. So today, Ms. Billinger will present us also a digital platform for market transparency of bio-waste availability. So you have the floor.
Thank you so much. Hello, everybody. Bonjour, guten Tag. Thank you so much for the invitation. My name is Marina, and I'm the founder of Leroma, which is a short name for a German long word, which is Lebensmittelrohstoffmarkt, food ingredients platform. And I'm doing food ingredients procurement for more than 15 years for food production companies. And about 4.5 years ago, I founded Leroma for making some steps of the procurement in a digital way to bring more transparency to the market and help food producers to find a better solution and source quicker and faster and cheaper an ingredient for the end product. So we are basically with the Leroma platform in the area of search engine where procurement employee can source and find and save a lot of time when he needs alternative supplier. We had lots of success during the Corona crisis, and after the crisis also we gained a lot of medium-sized companies from Germany who couldn't produce because their long-term suppliers were not available with the contracts they finished. My personal intention for making the market more efficient in terms of procurement is also a very sustainable way, because for me personally, it hurts when I throw away banana at home or my kids didn't finish their meal. We try to eat it up, right? And you know how it is in a household. So in my years with my various customers all over Europe, I saw so many waste products and it really hurt me. 20 tons of a great product, which is not being used in a final product, is being thrown away. So we started our marketplace for overstock, for residues, for primary products, but also half-finished goods, anything which can be processed. We try to mediate within the food industry, but sometimes it's not matchmaking the market. That means as we are like a young eBay for the B2B food industry, and not everybody knows Leroma. So please tell all your food producers whenever they have a problem with the overstock. The thing was that we didn't matchmake all of the surpluses we got on our platform, and we gained some customers outside of the food industry, which brings us more to the circular economy topic. So I have a customer from northern Germany who's producing vegan food, and they had some soy texturate, and it was like dated, so the expiration date was over, and they would have just bringing it to the bio waste collection, but we got a potential buyer for that product, and it was someone from the construction material production side. And now there are some walls existing with soy texturate, because all market prices went up, and they said, if it's a good price, we can take it. So our intention is to mediate through a digital database of suppliers, all kinds of ingredients, but also side streams and overstock of food products to potential buyers. And we do that in a library. We have a library of all functional ingredients, and mediate it to mostly medium-sized companies. Of course, we have some farmers and primarily production companies, but our main persona is typical medium-sized company in Europe. Our intention is to prevent and reduce the waste, so it doesn't come to that point. That means to make the procurement so efficient. But when it's not possible, we try to reuse or recycle it. But of course, we would love to stay in the food industry. So we have projects like companies. We work now with Fraunhofer Institute. They do double ferment cacao side streams and create a new extract for the beverage industry. And this is where Liroma comes into place, because we are very well connected with the procurement and with the food technologist. So we can give a completely new resource, which is made up of bio waste, to test how it's working. And for example, for now, it's being a great taste. You cannot imagine from cacao pulp. The taste which is being created is banana and lychee. And like we heard already today, it's all in the testing and in the laboratory side. But when we have a customer where I can help the network with, so whenever you need to test a product, we have food producers who would like to test new ingredients and new products made from upcycled bio waste. So our intention is also through more transparency, which we are collecting on the platform, to create more education for the production companies, that they of course do work with bio waste. For example, from this fish, they do fish oil and fish flour for years, but that they know that there is a possibility, when they make the right fillets and have the right equipment, that they can also increase the profit when they do, for example, collagen or even bioplastic out of fish skin. And this is where we try to be the mediator between fish skin supplier and also fish skin buyer, through connecting the transformation of knowledge and availability. So right now we have various industry groups, and we are looking for a project where we can work together on an upcoming category. This is side stream. So we have the infrastructure, digital infrastructure, and for us, it's not a big effort to bring on also side stream. Where is a side stream available, and who might be interested in a side stream, especially for being used again in the food industry. So the database is just very simple build up, like with an industry group, with the commodity groups, the raw materials, and then afterwards the technical criteria are very important. That's why we work, my co-founder is a food technologist, with this database, which is making the procurement way easier, as well as for side streams as for regular products. Our goals with our different projects is, of course, we have with a digital product, we want to increase the digital procurement setups and also to help companies to be more sustainable and prepare the sustainability reporting and the CO2 balance, but also to motivate the whole industry to prepare the side streams. And therefore, we have a project which is starting in May with RWTH Aachen, which is a small project in North Rhine-Westphalia, where we try to collect bio-waste from big companies and see how well is the data structured and how can we use this data to put it in the platform or through an API wherever you need it, and close the loops and the gaps and provide this data to possible business model. So I'm sorry, this is in German, but it shows that this integration of data can be used in so many ways for the future businesses for scaling. So I know my time is up, but just a short part. We are a young company. We have the direct access to the food industry, but also to primary producers, especially in our region in Germany. And we are looking for projects, for partners, and we have experience with big grants and consortium partners from all over Europe, but we are also participating in small regional grant projects. And if you are interested in that today or in future, or know someone who would like to mediate bio-waste products who are especially being used or could be used in the food industry, please remember my name and contact me anytime. Thank you so much. Any question?
Thank you very much, Ms. Bellinger, for your presentation. So, is there any question?
Can I have a question?
Yes.
Yes.
Yes. That's really interesting. I can say congratulations. My question is about how you create your database.
We started with Excel files. We just created it manually because there is no such database for all food ingredients worldwide. So we created the base, and then we wrote an algorithm where it's being connected, each ingredient with the special criteria is connected to some groups. So there's an algorithm in our technical site, and we can scale it now to 1 million ingredients or categories.
Okay, thank you.
You're welcome.
Okay. Yes, we're going to take a second question.
Just a short one. What is your business model behind this? Who's gonna contribute? The one who's buying, the one who's selling, or how is it working?
Yeah, the one who is selling, and we think in platform economy. So we have various business models on the commodity procurement, where we also act as a trader to help the companies, to, you know, get over with the emotional part, to also do sometimes just one deal with the overstock, because when we are a trader in a food production company, then it's easier for them to buy also overstock. So we have a physical warehouse where we store sometimes overstock, but basically the idea is to bring it from supplier to buyer. And another business model is that we get a percentage of the mediation part. Yeah, we take between 2 and 10% commission when the people meet each other and do business.
Thanks.
You're welcome.
So thank you very much. So now, welcome to our next speaker, Mr. Benjamin Caron, who is the co-managing director of Absolute and Smicon, a company that has specialized in bio-waste processing equipment since 1980. Mr. Caron, you have the floor.
Yeah. Thank you very much. Do you hear me well?
Yeah, it's okay.
I cannot find my screen. Are you able to see my screen just right now?
Yes.
Yeah. Okay, let me. So this is okay? Yes, okay. So thanks for your invitation. My name is Benjamin Caron. I'm the owner of the company Absolute. Absolute is a plant builder specialized in the waste treatment industry. We are also an engineering office, and we are the French representative, the French dealer of the Smicon company. Smicon company is a Dutch company, which is specialized in the bio-waste depacking plant. So you can see on this picture the product folio we are able to sell. We only have 10 minutes, so I will only focus on 3 different topics around bio-waste. So the first one is the bio-waste reception. You can see now the different kind of bunkers we are able to provide in the European market. We have some bunkers from 15 to 160 cubic meter bunkers that are buried in a pit. So this has the advantage to be directly fed by a truck. So the plants are much more clean due to these main arguments. So the trucks go directly into the bunkers, and you don't need to have a wheel loader to feed the plant. And then we also are able on a smaller scale to provide some smaller bunkers that are directly on the floor. So of course you need a forklift, you need a wheel loader, but you are able to have a much more less expensive bunkers. And now you can see some pictures of bunkers we are able to provide. So we always need this kind of bunkers to feed the plant. The main part of the depacking plant, of course, is the depacker itself. And Smicon has 3 sizes of depacker: SMIMO 80, SMIMO 120, and SMIMO 160. So this can go from 5 tons per hour to 20 tons per hour of depacker. So most in France, most of the bio-waste are supermarket waste, restaurant waste, household waste, and a bit some agro-food industry waste. All of these depackers works on the same principle. It means you feed these machines from the top with most of the time some screw conveyors. And then you have a shaft that rotates around 500 RPM. And this shaft, there are some hammers on it, and it explodes all of the organics with the packaging. This is not sharp edge, this is flat head. And then you have a screen surface, a screening part that separates the organics from the packaging. This is the only job of a depacking machine, is to separate organics from packaging. There are many suppliers of depacker in the world, and we have two main specificities on Smicon depackers. The first one is the fact we have some rotating drum for screen filters. This gives a real advantage to have 360 degrees screening surface. So we have 3 times or 4 times much more surface as our competitors on it. And all the organisms go out of the screen surface, not by gravity, but by centrifuge force. And due to this high surface of screening, we are able to put some smaller holes. And this is basic machines. The more smaller holes you have, the better organics quality you have. And we are able to have from 8 millimeter to 50 millimeter. But on most of the French new projects for customers that are interested about the quality of the organics, it holds about 8 or 10 millimeters diameter. The second specificities of our machine is that we have some hammers and they are flexible. This gives the main advantage to be able to rotate if there is some monster like big or hard particles inside the biowaste. We know that it can happen, and if this happens, the hammer can rotate and it will not break. So we have some operating costs that are really low compared to other type of industries. So this is the Smimo depackers. Then we have also some after treatment solutions. The question is why? I will try to explain you in a easy way. You can see on this screen. I'm sorry, this is in French, but this is the new law in France that gives you the amount of plastics or different particles inside the organics that you are allowed to have. So it gives 0.3% of plastics, 0.3 on glass, 0.3 on metals, and all of them combined together 0.5 maximum. So this can be for a lot of people really hard to achieve, but for us this is quite easy. But in fact, I have an example. If we are able to give 3 times better quality, I mean 0.1% of plastics with a 10,000 tons plant, 1,000 tons per year plant, it gives at the end 2 tons per year of microplastics in the fields, in the digester. And if we put it in the equivalent of plastic bottles, it gives 58,000 bottles in the field that everybody can understand this is not sustainable and not possible to do it in the near future. This is the reason why Smicon, since many years, developed some after-treatment solutions. So there is 2 types, one for the organics and one from the refuse, and I will develop all of them. For the organics quality, so it means after the depacker, Smicon developed a belt separator. So this is a machine that will treat the organics, so the soup, and will make a fine screening with 4 or 5 millimeter to help removing all the small plastics. So this is the belt separators, just to make a cleaner fraction. Then we also have some another machine, which name is the Cyclone, from Smicon, is just to remove the heavies from the organics. The heavies are the glass fraction, the shells fraction, and the stones also sometimes. So I will show you in this video. You can see on the green part the full cyclone, which is plug. We could say a plug on the silo, and this cyclone will allow us to remove on supermarket waste all the glass, like you can have on the glass fraction. You can remove also the shells of the eggs that you can see on this picture, on this movie. And it can also help us to remove the metals from the organics. So this is only to remove heavies from the organics. Then we after the depacker, we also have packaging, a refuse stream. And in France, the cost is around 200 tons, 200 euro per ton. So the aim is to remove organics from this. And this is a wind shifter. And it just helps to blow the plastics and not the orange peels or heavy organics. So it allows to take this back. Then we also have a screw press to remove all the juices and all the liquids that are inside the packaging fraction. And just as an example, as a video is always better, you can see this is after a depacker. This is all the packaging. And you can see on the slope the bio-waste that are really, really dry because there is no more juices inside. It's very slopey. So the aim is to remove all of the juices. And we can see in our feedback, we remove around 30% in weight of the total amount of packaging. So just to give an overall indication, we are able to provide this kind of plants, smaller ones from 5 to 10 tons per hour with smaller bunkers, bigger ones, and then much bigger ones for big plants and with a lot of after-treatment solutions. And then I think we are on the 10 minutes. So this is our contact for French countries. We are only responsible in the French countries and SMICON directly for all over the world. And thanks for your attention.
Thank you very much. It was really interesting to see how is it really working, because we talk about deconditioning, but without knowing exactly how is it working. Is there any question about the process or about the company or about the presentation in general?
Yeah, I would like to know if there's any plant in Germany. You have realized a project in Germany?
Yeah, I'm sure there are a lot of, but to be honest, I can send you the reference list, but this is not my country. I've already visited in the past, but I don't remember the name. I know there are plenty of plants like this from SMICON, but this is not my territory. So I will ask SMICON to give you, I'm not able to tell you that.
And what about your products? Because the first part, you had also your own products, right?
No. It's all the products comes from SMICON, but in France, Absolu is only the French dealer in the French market only. So I don't know what is outside for France, but I will give you a short email after that meeting to give you all the reference all over the world and not only in France.
Yes.
One more question. Okay, so let's move on to our...
Timo, you have a question? You just... No.
Yes. I would like to know if the problem of microplastics is addressed at all. Can you give an idea of how big the problem is, or have you investigated?
The problem for France is only starting because this is a new law. The bio-waste in France is a new market. I think we are less than 10% of the French population that actually treat their bio-waste. But we know that in 1 or 2 years, it will be 90 or 100% of the population. And we know that in the countries that already made some depacker since many years, like in Scandinavia, they really want to remove all of these microplastics because it cannot be sustainable. So they have to remove it. At the end, this is for our kids. This is we need to make something better. And there is no depackers in the world that is able to make 0% plastics in the organics. This is mechanical sorting. This is not IA or something like this. You have to have some small parts, the smallest possible, and then you have to put after treatment to try to get as clean as possible.
Thanks.
Okay, so welcome to our next presenter, who is Alexandra Brautlacht, who is researcher assistant from TIR, thermal processes and emission control in waste management and recycling teaching and research unit, which is based in Aachen. So the title of the presentation is From Bio-Waste to Biochar, Carbon Sequestration, Soil Amelioration and Beyond. Mrs. Broutlaert, sorry. You have the floor.
Thank you very much. The pronunciation was actually really good. Thank you. Okay, thank you. I think you can already see my screen. Okay, good. Thank you very much. First of all, I would like to say thank you for inviting me. And I want to give a short overview into my research field, which is biochar. So my title is From Bio-Waste to Biochar, Carbon Sequestration, Soil Amelioration and Beyond. And I come from the unit of thermal processes and emissions control in waste management and recycling. We just changed our name and it's really long now, so I also have to get used to that. But we are part of the RWTH Aachen University. And I would like to start off by introducing our research fields. Our main focus is thermal waste treatment, so waste of all kinds. First off, starting with municipal waste streams and the classical thermal treatment of waste, which is waste incineration. But we also focus now, I think for the last 3 years, we also have a research assistant who focuses on the chemical recycling of plastic waste, so pyrolysis of plastic waste. And then we have our group that is the energetic biomass utilization group, so which I'm also part of. We focus, one field is sewage sludge treatment, as in Germany, the phosphorus recycling becomes legally obligatory into 2029. We have now a couple of projects really focusing on phosphorus recycling out of sewage sludge. There we mainly also focus or only focus on incineration of sewage sludge. But for other biogenic wastes, we go the route of pyrolysis, and that is also what my talk will be about today. So the creation of biochar. And then we have a third work group in our unit, which is basically catering to the first groups, which is the gas and measurement technology. So here really we focus on different technologies for measurement of emissions and reduction of emissions, and also the measurement of how our gases from our thermal treatments, what they compose of. So also the determination of syngas production from our gasification processes. We also have our own little lab, so we can do fuel determination or determination of our solids, of our solid products, as well as our input streams. That is really practical, as we're not so dependent on an external laboratory. And then we have our technical center, where we do most of our experiments, and where I also will show 1 or 2 pictures from our pyrolysis plants. This is our team. We are now, as of now, still 14 research assistants in all our work groups. And we work under our lead, which is Professor Quicker. And we have a little more than 17 student assistants now. I think it's around 20-ish. And then because we are part of the university, we also do a lot of education and have a lot of courses, and also have 10 guest lecturers that are part of our unit. Okay, now into the field of biochar, which is really my field of research, what I do. So first of all, the question, what really is biochar? So biochar is the solid product out of biomass pyrolysis. Biomass pyrolysis means we treat the biomass without having oxygen in the system. So we do not burn our feedstock, we just heat it up and get rid of the volatiles. The volatiles move out of the biomass, and then we are left with a solid product, which is very high in carbon. So it can have up to 90% of carbon, making it very stable over time. And the other side products that we gain out of the process is, first of all, the pyrolysis gas, which contains highly flammable products, so we can still use it for energy generation. It has high contents of carbon monoxide as well as hydrogen, so we can use it in an incineration and then use the heat to fuel our process and also gain a surplus of energy out of it. The second side product out of biomass pyrolysis would be the pyrolysis oil. The pyrolysis oil is the lowest percentage of weight that we get out of it and can be used also for fuel purposes or other purposes, but the use of pyrolysis oil in biomass is still very much in the lab scale. The pyrolysis oil gets very important more in the chemical recycling route. So the plastic recycling pyrolysis, there you really aim for the bio oil or the pyrolysis oil. This slide shows our ideal idea of biochar production and also shows the different use points and application routes. So we want to always use waste products. We do not want to use any biomass that is in conflict, for example, with food industry or other virgin woods. So we really want to focus on waste. So mainstreams are waste wood and agricultural waste streams or waste streams from food production. Then we go into our pyrolysis. We use the pyrolysis gas that we create in an incineration route, reuse the heat for our process, and also can decouple heat that is in a surplus. Then we get our product, which is our biochar, and then we can go into the two biggest application routes as of now, which is first agriculture. In agriculture, the biochar is a way of really making the soils better. It acts as a battery for nutrients and as a holder of water. So for very depleted, nutrient-poor soils, the biochar can really make the soils a lot better. The other thing is that you disrupt the carbon cycle, so the biomass doesn't degrade anymore and doesn't become CO2 or methane, but it stays as a carbon in the soil for a very, very long time, basically making it a carbon storage route. So that is the use in agriculture. The other field that is really interesting is the use in metallurgy, because the metallurgy sector really has to think of alternative routes, how to replace their fossil fuels. And one of the biggest idea is using hydrogen as an energy source, which is also absolutely what we think is the route to go. However, for example, for steel production, you also need a carbon input into your process. Otherwise, you cannot make the iron into steel. And that is why we plead for a joint system where you use biochar as a carbon source and hydrogen as an energy source. So those are really the main fields that we work on in projects right now, the agriculture field and the metallurgy field. So in small scale, what does it look like? We have our biomass here, for example, a picture of a wood. Then we heat it up. We have no oxygen in the atmosphere, so the volatiles escape our biomass, and then we are left basically with the carbon skeleton of the plant. And the biochar then consists of a much smaller amount of volatiles than the biomass. The ash is still part of the biochar, and then we have the so-called fixed carbon, which is basically a calculated number, and but it is very rich in carbon, our product. So what projects we have right now, I will skip over them because I'm already seeing the time limit coming. We have a project where we make biochar out of horticultural residues, one where we go from a fermentation process and we use a fungus to make biochar. And then we also have some mainly industry-funded projects in the metallurgy. And these are the systems where we do it. This is our batch retort in our technical center. This is a batch process. And then we also have a continuous reactor where we can go with approximately 10 kg per hour of biochar production. And then I thank you very much for your time.
Thank you for this really interesting presentation. Is there any question?
I see one question by FMAR. Yeah.
Mr. Marco-Vecchio.
Thank you for your presentation. I have a question about ashes and biochar. For you and in Germany, biochar and ashes are fertilizer, waste, input for fertilizer?
Do you mean legally or
Yes.
Okay. Yes. So yes. So now the legislation also has changed so that the that biochar can be used as a substitute for fertilizers, although technically that's why I asked about legally or technically, because technically I would always also use, that's why I said the biochar is more of a battery. You should always include also a fertilizer to the biochar and mix it together because it can really hold the nutrients, but the biochar itself doesn't really give the nutrients.
Okay. And for ashes?
Ashes are, I don't, I think they definitely have to be also pre-treated, but I'm not 100% sure because that is not really the field that I'm currently the expert for. I'm sorry.
No problems. Thank you.
Thank you very much. So we will have still 10 minutes for one presentation. So to end this really interesting session on bio-waste, I give the floor to Mr. Benjamin Laulier, Business Unit Manager from Synaptech, Ultrasonic Technologies, a French company specialized in the development and implementation of ultrasound technology. Mr. Laulier will present us power ultrasounds for food industries from raw materials to waste. You have the floor.
Well, at least I will try, to be honest. So thank you for giving me the floor and for the invitation. I will try to go as fast as I can because we are a bit late. So As you said, I am responsible of liquid processing activities at Synaptech, and I will introduce you Synaptech indeed. What do we do at Synaptech? We are a small company indeed, based in Lille, north of France, really near the Belgium frontier. And our core business is the development and the manufacturing and the design of ultrasonic system, no matter what the application is, because there is a lot of application when you are talking about ultrasounds, yet available in industry or still in R&D. Synaptech was founded in 1984, so now we are in our 40 years. I was not involved in the company at the very beginning, okay? I joined 5 years, and since then, we have still at least 50% of our team, small team, we are 20 people, 50% of our team is dedicated to the development, continuous development of our ultrasonic technology, which made us able to work in different fields and to be involved in also R&D project and European projects as well. So we have the pretension to say that we do have really unique ways to work with ultrasounds, because you can find people or companies that are providing ultrasonic technologies, but only dedicated for one application. It means that they not necessarily know how ultrasounds are working, but they know perfectly well how to use them in their process, in their typical applications. This is not what we are doing. We do focus on ultrasound technology, using a patented-based technology, which allow us to work with a computer and to being able to trace every data, every ultrasonic data. It also allows us to perfectly see what's happening inside the process. Even if we are working with ultrasounds, ultrasounds for us are not only emitters of ultrasounds in liquid or in solids. They are also receivers of information of what's happening inside the whole process. Okay, some key figures, small ones. So as I said, we are a small company, 25 people. 50% of our team are engineers or technicians, highly skilled in ultrasounds. Even if we are small, we are able now to produce and to manufacture and to sell worldwide about between 2,500 and 3,000 ultrasonic systems all around the world, no matter what the application is, if the application require ultrasound and if, acoustically speaking, it is justified. So you do have a lot of kind of application when you are using ultrasounds and where ultrasounds can be useful. Here you do see that you can treat or process liquid with ultrasounds with homogenization, degassing, cleaning application is the most well-known use of ultrasounds, but you do also have other applications which involve ultrasounds, such as cutting, welding, and you can also use ultrasounds in medical applications. In the ones which are rounded by red lines are the ones that can be used in food industries. Indeed, you can use ultrasounds to make extraction of biocompounds from raw materials. It can help, or it can be included in a production line in order to produce a product. Indeed, and you can also use ultrasounds in dry contact in order to definitely slice cakes, slice cheeses, or you can also use ultrasounds to weld some packages for food industries. These are really well known in many fields. But here we are here to talk about food. So these applications are used yet in food industries for cutting and welding application. You do also have application when you can use ultrasons to defoam some carbonated soft drinks, for example. When you are bottling liquids inside bottles, before the bottle is closed, okay, you will have the production of foam. And unfortunately, if you do have foam, which will definitely go through and go outside the bottle, you will pollute the outside of the bottle, and then you will have to rinse it. If you are using an ultrasonic system for breaking the foam while it is bottled, you can definitely increase the speeding line of the bottling lines speed, and you can definitely save water. These are applications which are more familiar for me because I'm a chemical engineering engineer. And so in food industries, you can use definitely ultrasons for homogenization purposes, for degassing purposes, for cleaning purposes, indeed, and for cell lysis processes. So what's happening when you are using ultrasons, okay, power ultrasons to be more precise, in liquids? What will happen is that you will produce cavitation bubbles, okay? Cavitation bubbles are really are small bubbles which are created in liquids, and these bubbles are not stable inside the liquid. So they will definitely have an impact on particles inside the liquid, for example, and they will definitely promote local scale reaction at the size of a cavitation bubble, which could be something like few nanometers. I do have some videos to show you what the impact of cavitation, okay, inside the liquid. If you do see here, these are aluminum foil, okay, and when you do are promoting definitely cavitation inside the liquid, you will have some physical change on the aluminum foil. These physical change are the cavitation bubble, which are imploding in front of the aluminum foil. And when you do definitely make the process continue, okay, you can even definitely break the aluminum foil. This is the very same process when you are treating a liquid with particles, for example. Here, this is another film to animation to show you what could happen when you are submitting definitely a flow which containing particles with ultrasons. In fact, what you will do is that creating cavitation bubbles, okay, in front of particles or near particles, you will be able to decrease the size of these particles. It will allow few things, such as, for example, being able to make the digestible part of a particle be more available, okay? Or it will also allow to have more access to a particle or to a compound you want to extract from the particle. This is the main principle of it. What's happening when you are treating, for example, sludge, when you with ultrasons? What will happen is that this is the very same principle that here, okay, you will definitely being able to reduce the size of particles or agglomerate, and it will definitely permit to increase the digestible fraction of your sludge for bacteria, for example. can permit to increase the methane production yield, and can also hygienize sludges, because the cavitation phenomenon is not really specific to one application. Okay, this is a phenomenon which definitely can be used in many kind of applications. So it can definitely break some cellular walls. Okay. And what's the interest to use ultrasons in such kind of application, or even in other applications, is that you can definitely imply it or make it work in existing installation. And even with conventional unconventional techniques, and it is an energy efficiency techniques. And what makes us different as well is that as we are manufacturer of our own equipment, we are also able to manufacture them on different constraints and on specifications, which allow us now to being able to couple our ultrasonic technology with microwave technology, for example, or supercritical CO2, for example. And somehow in some application, coupling both technology can definitely have synergetic effect. So as you probably understood, I'm not specialist in sludge and bio-waste technology, but how do we generally to prove that ultrasons can or cannot work? I'm not saying that ultrasons can work in every application, but we do have some equipment for making some tests. And then after tests were made, and if the ultrasons can work or are working, we do have the capability to definitely manufacture the equipment that could be used in production configuration or in continuous operations. We will be at Anuga Food Tech. Okay, I will not be there, but my colleagues will be present. But they are not chemists or liquid processing specialists. So maybe if you do have some specific question, they will not be able to answer, but they will redirect me directly the questions. Thank you for your attention. I hope I was not too long.
It's okay. just finish. Thank you, Jean. Maybe do we have some question? I don't know. Not so much question.
Okay, so thank you to all our presenters today, and thank you for attending this session. I give the floor to, I don't know if he's still there.
To me?
Gregor, yeah.
Oui, je suis encore là. Yeah, it was a lot of presentation, a lot of insights we have learned during this almost 2 hours, I see. So thank you for your kind moderation, Miravo. You've done a great job, and of course, thanks again to the presenters and your insights and knowledge. So we would like to share that also on the B2Match platform. So if you can send it to us, we will share it also with the participants afterwards. And as you know, it was recorded, so we can hopefully provide you afterwards also the link. And yeah, let us know if we can somehow assist with Emily and Miravo to bring some of you guys together, or some to create some projects Franco-Allemande. And yeah, it was a pleasure. Thank you. And yeah, we will be at Anuga Food Tech next week, so let us know if you have any issue. Merci.
Thanks.
Merci beaucoup.
Bye.
And,
Thank you.
Thanks, everyone.
All the best.
Danke, merci.
Dankeschön.
Dankeschön.
Auf Wiedersehen. Auf Wiedersehen. Tschüss. So. Patrick, ich glaube, wir können die Aufzeichnung beenden. Aufzeichnung.
Stop the
We
register.
can stop the recording, I guess, huh?
Maybe.
The Oscars have been already. Otherwise, we could apply with this video. No. Patrick, still there? I can stop it now, right? Aufzeichnung abbrechen, ne? Oder?
Ja.
Oder anhalten.